Hello CFD community, my name is Adrien Lavaux. I am in charge of the development of UniPlot, a data analysis and visualization software widely used in the industry, developed by Enterprise. Today I want to share with you how you can explore new frontiers in post-processing with a seamless converged data analysis based on UniPlot. In CFD, we invest enormous resources in creating accurate models, running massive simulation and tuning parameters. But how often do we get stuck in the last mile, making sense of the results, comparing runs, and communicating them clearly? At the end of the day, your simulation is only as impactful as the way you analyze and present it. That's where UniPlot comes in. As we explore new frontiers in engineering, tools like UniPlot ensure that engineers can move beyond raw data into real insight, quickly, consistently, and professionally. Why am I here today with you? Well, several Converge users decided long ago to rely on UniPlot for that. This sparked a great collaboration with Convergence Science. We built a dedicated UniPlot add-in that reads and organizes Converge out files natively, making post-processing of those a whole new experience. UniPlot is built on 4 core pillars. First, dynamic test data analysis. We are talking time series data here. 1D signals, sensor readings, measured trend over time. Second, static test data analysis, including 2D and 3D maps, often used for calibration or control surfaces. Third, automated report generation. Everything you analyze in UniPlot can be exported to clear, publishable documents, Word, PDF, PowerPoint, you name it. And fourth, full automation via scripting. With our in-house language Uniscript, think Visual Basic for Excel, every manual action can be turned into repeatable, coded logic. But what really makes UniPlot unique is its graph quality and customization. You can tell your story visually with control over every detail. In reality, there is a 5th pillar we added for non-programmers, the sequencer. It's a code-free automation module and lets users build full data workflow visually. If you have ever used Scratch, LabVIEW, or even flowcharts, this will feel familiar. Conditions, loops, file processing, all without touching a single line of code. The sequencer makes automation accessible and intuitive, whether you are an engineer, researcher, or data scientist. I'm not here to tell you what UniPlot could do in theory. I'm here because many of you are already using it in your daily Converge work. And what we hear from users is consistent. They love UniPlot because it makes their life easier for creating professional graphs, whether it's multi-axis plot or publication-ready figures, or both, for comparison tool and template-based analysis, so repeating analysis across runs is simple and consistent. For its ease of use, engineers can get results quickly without a steep learning curve, or for the analysis tools and visualization options, from cursors to cycle analysis to synchronized video, for standardization of colors, formula, and workflow, which is especially important in team environments. And finally, the effortless export, directly to PDF, PowerPoint, or Word, making reporting a one-click step. These are the reasons UniPlot has become part of the workflow for some Converge users. And the question I'd like to leave you with is, what will you use it for? So, some of you already know what you use UniPlot for today. But over the year, we have added capabilities that go far beyond the usual plotting or reporting tools, features you simply won't find elsewhere. For example, UniPlot offers advanced visualization tool for complex dataset, the code-free sequencer we already mentioned, unlimited access customization, free online training to help teams get up to speed quickly, and one-click tool to transform your data, which I'll show you in just a moment. All of these are designed with the same purpose, to make analysis fast, repeatable, and easy to share across teams. Now, UniPlot is more than just software. We have built an ecosystem to make sure users always find resources, training, and community support. You'll find us on our website, YouTube, where we publish tutorials and demo and tricks, LinkedIn to stay updated on news, events, and product tips, and regular webinars, where you can learn UniPlot, Uniscript, or see new features in action and ask questions live. The idea is simple. Whether you're getting started or scaling UniPlot across a team, you are never on your own. You always have resources at hand. Now, this is something I'm particularly glad of. A dedicated UniPlot section has been added by Convergent Science inside the official CONVERGE download hub. So if you are a CONVERGE user, you will already find 3 resources waiting for you there. A generic UniPlot introduction, very similar to what I'm showing today, maybe to share it with the other interesting colleagues, a setup guide, step-by-step showing how to connect UniPlot with CONVERGE files and create your very first plot, and a demo workspace designed for the UniPlot sequencer, so that you can follow the guide and try things hands-on right away. In other words, UniPlot isn't just compatible with CONVERGE, it is closer to you than it has ever been. Enough talking, let's see UniPlot in action. Over the next few minutes, I'll walk you through some of the key ways UniPlot makes working with CONVERGE results faster and more effective, from simulation comparison to cycle analysis to embedding results directly into reports. Think of this demo not as me showing all the features, but as a teaser, a selection of practical tools that you can start using right away on your own CONVERGE data. Let's break the ice. Here is UniPlot interface. I will import CONVERGE results directly into UniPlot. But first, I like to come back to CONVERGE folder structure when you create a simulation. For one case, you will have different outputs, the original one, some restarts, your in files, and then different stream per output. Here, I'm gonna work on stream 0. Remember this structure because we're gonna base the input on that. So I'm going to go to File, Import Data, gonna select this one. So you see I have the original one, the restart, some in file, and some different stream. I'm gonna take this one, whatever the out file you select, and you click on Open. When you click on the folder name, you can see the content. So here nothing, here some input and echo file. If you don't want the in file, for example, you can unselect this one. But here I'm gonna have it, and click on OK. And the file is loaded. See, here we can see the content. We mentioned echo file, in file, and out file, and we can navigate to see what is available. We have 4 input file, 1 echo file in this example, and then all the out files. And then if I go and navigate through, for example, array average flow, I will see all the channels. Let's make that wider. We have the crank channel and then the rest of channel. As channel names must be unique, we created a given nomenclature for the name. So here it's an out file, the name of the file, and the channel name. And sometimes we have extra information like the bond ID. So you see, no struggle with Excel, just a single import filter in UniPlot and all the data of the case is easily accessible. Let's go a bit further in the data broader analysis. What do we have here? First, the case name, the one that we created when we imported the file. Then, all the graphs that you can plot in UniPlot. There are a lot of them, so do not hesitate to review them, and we made video on YouTube to explain what they do. And then the channels that will be plotted in the selected graph. Also, feel free to go through all the files that you have imported. You can navigate there. And you see all the data in the same place in the data brother, easily accessible. Let's work on a simple plot. I'm gonna create a simple document. Select YT diagram. I'm gonna plot, let's say this one. I click on load. The channel has been plotted with the correct crank angle degree. Nothing to do, nothing to select. UniPlot finds it. And for a simple plot, let's do simple things. I'm gonna add some cursors where I can navigate through the data, and I have some information here. Position the cursor, difference on the same signal between the cursor. But that can go further. I'm gonna close that and add a cursor data table. It's a table that will sum up all the information based on the cursor position. You can add a bit of statistics if you want. Let's put everything. Okay, maybe that's too much. I click on OK. And then I have my cursor table. I can change a little bit the look if I want. Let's put a bit of gray. Not that one. Okay. And then maybe I might want to put some conditional formatting here. So I'm gonna go red if my channel is above a given value. And now I'm gonna try to change that. You see, the table is updated based on the cursor position and the conditional formatting also. Let's plot another graph and we'll see another nice feature. So let's take, for example, okay, that channel. I'm gonna plot it. And I will add a 2D point on that one. Up. So let's say I want a point at position 1000, y equal 1000, up, and the point is here. But the good thing is that if you exchange the dataset or the simulation, it will always plot you the first point that reach 1000. And those are just few of the features you can encounter in UniPlot for simple plots. Let's try another plot. I'm gonna add a new page. And I'm gonna select an XY plot. I'm gonna plot a specific channel. Okay. By the way, you see again the x-axis is properly selected. And I'll plot that. And you can see that UniPlot is telling you, okay, this is cycle 0, then we have cycle 1, 2, 3, 4, etc. So when you analyze your simulation, you already were in the cycle you are. And so that's really great, especially when you work with cyclic simulation. I think that's the moment to show you customization possibilities. Let's change a little bit the color of the line. Let's go for maybe a bit of red. Maybe thinner. I can add some symbols. Let's put them blue. And a bit of fill color that would be maybe transparent if needed. That can be interesting with some specific user color. And you can see with this level of customization, there is nothing that will stop you to pass the message you want. So I hope you like the cycle plot, but we have another one. So let's go for this one, 2D XY cycle. We keep the same inputs, click on load. But now we are gonna tell UniPlot to split the cycle. Plot my curve. So in fact, it's the same data, but now we have split that. Where are the graphs? I'm gonna switch to waterfall mode, and here I have all my cycle. Really easy to compare for a cycle to cycle comparison. And let's say this one, I want to highlight it for some reason for my presentation. I can do that. Let's add a third page. I'm gonna, well, I like this one. I'm gonna plot it as it was before. Okay, and I want to do a simulation comparison, because the idea with CFD is maybe you tweak the input parameters and you want to check one simulation with respect to the other one. How would you do that? I right click. I'm gonna exchange just for that page. You can exchange on the document level or page level. And I'm gonna add a file. By the way, I could just replace and take a new simulation. I was working with data from CONVERGE 5. Now let's take the same simulation in CONVERGE 4. Nothing to compare. The file has been loaded. I can, by the way, ask the file 1 to be, let's say, dark red, and the file 2 to be in dark green. And OK, and OK. Time for comparison. We can see some small differences. So now, how to analyze those? Well, let's use UniPlot Power for that. I'm gonna select both channels, right click, multiple data set. I'm gonna create a difference. So I'm gonna move this difference to another axis to be able to zoom on it. Maybe let's put that one on the top, that one on the lower part. And I want to, let's say, find peaks of the difference. So I'm going to right click here, open a new data set, find peaks. Okay. And here you see, let's put them in blue to make them more obvious. You know, it's a good way to quickly find the big differences between the two simulations. And then I have even more tools. I can right click on this new data set that I created and create a table out of that. Okay. And here I have the moment where the difference happened and the value. And again, if needed, I can add conditional formatting. Let's say when I am above 100, I will be in red, or red, and click on OK. So here, just one. Just to give you an idea of what can be done. It's also the moment maybe to add a legend for the data file. So we have that one. You can again prepare the diagram as you want and as you think they would fit better in your report. So we can do that on the file level. We can also add a legend for the 2D data set. And maybe we can change that channel name instead of the legend. And then it's a little bit better like this. So we have done different plots. We have done comparison. We have added legends, conditional formatting. Now let's go again one step further with one thing I really like, which are the placeholders. So here I'm going to take the channel info table and I'm going to select, let's say, a few channels. I'm going to click on load. And here for each of the channel, I can select, for example, the max value, the first value, and this one, last value, standard deviation. And here, for example, also the time of the maximum, or here that would be the angle. I'm going to click on OK. Everything is being computed. And I have my information in a table ready to be used in the template. And whenever you load a simulation, those values are again updated, replaced, and if you put conditional formatting, it will work the same. So you see all the features UniPlot is putting in your hands to properly analyze the simulation. But there is more. Let's go for a new page again. Let's find, okay, maybe this signal again. I'm gonna now plot that one. I'm gonna click on load. And I can modify the data. So different ways to do that. First, the most accessible one would be filter function. Like, for example, I can smooth my signal and the signal has been smoothed. And if I want, I can maybe add a new filter. Like, for example, differentiate it. Okay. And I zoom and I get the differentiation of the smoothed signal. And maybe on that I want to add a threshold. So let's say for 10. So you see, easy to see. So we have just seen that we can make data transformation inside the template, but there is also a way to go and see the data directly and create formula. You can right click here and add either a simple formula. As an example, you would call it output equal absolute value of input. And you can also write multi-line formula. Take the output 2 equals differentiation of the first output. And you can write pretty complex things in this simple interface that is stored in the formula database. And every time you load a simulation, this is being reused. And because I could not finish this presentation without a nice CONVERGE simulation, here is an example of embedded video with a simulation linked to our graph and cursor data table. CFD is about exploration, but exploration is only complete when we can communicate what we have discovered, and UniPlot turns CONVERGE results into insights that are easy to understand, share, and publish. Check out UniPlot on the CONVERGE Download Hub or directly at uniplot.com. Try the add-in and see how it transforms your workflow. Thank you very much for your attention today.